Hello, and welcome back to the final IB Math speedrun for Chapter 7. And so in this speedrun, we're going to be going through cyclic integration by parts. So let's jump right in. So how does cyclic integration by parts work? Well, we need to really just do a question on this, and there are not too many that were given to figure out how it works. So I'll just do one of the questions. Use cyclic integration by parts to find the following. So the first one is tan x secant squared x dx. So we need to integrate this by parts. So of course I'm going to which one? I'm going to pick this one as a derivative, and so this is tan x, and so u is equal to tan x, u prime is equal to secant squared x. So what we get if we take this out is that we get tan squared x minus the integral of tan x secant squared x again. And so here's the funny thing. If we keep on doing it, like if we keep on trying to do integration by parts, we will just end up with the same integral over and over again. And we can actually use that to our advantage. Because if we have both of the same integral on these two sides, we can simply subtract the integral from both sides. So we get 2 tan x secant squared x is equal to tangent squared x. And so the magical thing is, if we simply divide both sides by 2, we get that the integral that we need to find is simply equal to the tangent squared of x over 2. And so that's cyclic integration by parts in a nutshell. It's where we use the product in the integrand. It's when we integrate the expression by parts twice or once to give an expression involving the same expression, and then it allows us to isolate I. So yeah, tan squared x, of course, plus c. So for the third one, we have the expression sine 2x cosine 3x dx. So let's find this one. So I'll say u is equal to sine 2x. U prime is equal to 2 cosine 2x. V prime is equal to cosine 3x. And v is equal to 1/3 sine 3x. So we get that this is equal to 1/3 times sine 2x times sine 3x minus the integral of 2 cosine 2x. So it's 2/3, 2 cosine 2x essentially, times 1/3 sine 3x. And so it's important that we differentiate the same function and integrate the same function if we haven't got the original function yet. So what we get is we differentiate this. So this is u is equal to 2 cosine 2x. U prime is equal to 4 cosine 2x. V prime is equal to 1/3 sine 3x. Oh, sorry, wait. This is negative 4 sine. And then so v is equal to negative 1/9 cosine 3x. So this is then equal to minus 2/9 cosine 2x cosine 3x. Oh, sorry, plus actually, plus 2/9, since it's negative 1/9 negative here. And then we have plus the integral of negative 4 sine 2x minus 1/9. And so now we can combine them. Now we can say this is plus 4/9 sine 2x cosine 3x. And so now we're ready to combine these functions. So since this was the original function and this is 4/9, if we subtract it from both sides, we will get 5/9 of this original integral sine 2x cosine 3x dx is equal to 1/3 sine 2x sine 3x plus 2/9 cosine 2x cosine 3x. And so if we multiply both sides by 5/9, we get that our integral sine 2x cosine 3x dx is equal to times 9/5. So we have 3/5 sine 2x sine 3x plus 5/2. Oh, no, I did it the wrong way around. Plus 2/5 cosine 2x times cosine 3x. So that is cyclic integration by parts. Yeah. Yep, that looks good. Okay, on to the final question. And that one is, we have the integral of sine squared x dx. So we integrate this, u is equal to, I mean, if we could also alternatively do this in a different way, using double angle theorems, but let's not. For the purposes of this exercise, let's say that u prime is equal to cosine x, v prime is equal to sine x, v is equal to cosine negative cosine x. So we get this is equal to negative sine x cosine x plus the integral of minus the integral of cosine squared x. I believe, or is it minus cosine squared x? And yeah, I guess we could continue again and get sine squared x, but I'm just going to fast forward a little, because minus cosine x is equal to -1 minus sine x. So we get that this is equal to minus zoomed in, to -1 plus sine squared x. And so we can split apart this integral. So we get plus x minus sine squared x. Minus the integral of sine squared x. So we get that 2 times the integral of sine squared x dx is equal to x minus sine x cosine x. So if we divide both sides by 2, we get the integral of sine squared x is equal to x minus sine x cosine x over 2. So this should be our answer. Yeah, looks good. Plus C, of course. So that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one. See you then.